Para los que no me conocen, pues mi
For
nombre
those
es...
who don't know me, I'm Aida Lorenzo. I'm the new coordinator of the community of practice for bioenergy from Let's Luck. I see several members of the community. The idea is having a lot of information regarding bioenergy, and today we have a presentation that is really important for us, which is about the potential of hydrogen production and use. And we've requested our guest that starts in a general way, but to tell us how this relates to bioenergy, which is the subject of our community of practice. For today, we're going to have simultaneous interpretation. Please, you need to select the language, either English or Spanish. So please select the channel of your preferences, your preference. You need to click on the bar down below that says interpretation and select your channel. As a reminder, because there are people that are joining for the first time, well, basically, we are the bioenergy community of practice from Let's Lab. We are a community, we are a peer-to-peer learning network. As a community, we see the needs of each country regarding bioenergy. Then we also have a group learning, like we're having here today, about several topics proposed by the community, and we have networking activities to see how we can exchange experiences. This is really important. In my case, I started as a community member a year and a half ago, and this experience exchange has been very helpful in order to know what the other countries are doing. One of our guests today, well, I met him through a networking activity, and that's why we invite him here today. The idea is being aware of what our colleagues are doing in their countries. And this community is composed by several countries, and in Latin America specifically. And as a reminder, we're going to see what we work on the period from 2020 to 2022. We work about integrating bioenergy into national energy and climate policies. We've had online sessions, just like the one from today. This is due to the pandemic. We discuss innovative technologies, policy frameworks, business models, and tools that can be used to develop bioenergy in our countries. Another important thing, we have access funds to provide technical assistance to the community members. Basically, we have 5 technical assistants that, well, I'm sorry, 7 technical assistants that have been cleared. I'm going to tell you a bit more about this. And also, we need to transfer the technology and the knowledge. This has been very helpful to know how the governments have implemented certain regulations. And this is not the exception because we're going to know how Chile is working, specifically in the H2 network. So please go to our website. I share the link. There's the link, and I'm going to ask Astrid to share the link on the chat. I'm not gonna spend too much time here because I don't have much time, but we had 2 technical assistants for the community members. We did the selection in December, and it's gonna start on this. This is the first 5 projects that we're gonna do with the RAISE project. These are implementation projects in order to manage the project concept on how to seek for funding. These are 3 from Colombia, 1 from Guatemala, and another one from Honduras. They have started this technical assistance, and the idea is that all members can access this information and we can have sessions to know the outcomes of these projects.
Aparte, tenemos otra asistencia técnica.
Besides, we have other technical assistances that is Climate Help Desk. We have allocated 3 technical assistants related to bioenergy. In this case, this is about the biogas and biomass also. And we're going to give another technical assistance with other community because there are several communities within Let's Lab. We are working with the Articulac community and we're going to have another technical assistant. So as you can see, what we want is that this community can be very active and you should also feel supported by the community and we need to have a lot of knowledge exchange. If you want to join the community, you can register through this link. We leave you there the QR code, and we're also going to share the link on the chat so you can register. And to the ones that are already members, please follow this link because we want to know about your expectations from the community and maybe you have a change institutions or any information. That way we can update our database. We also have a chat group, a WhatsApp chat group to comment on topics related to bioenergy. And we leave you here the QR code as well, so you can follow it. There are, the link is going to be shared on the chat as well. So first, you register and then you can access the WhatsApp chat or the WhatsApp group. Now, I'd like to introduce Pablo Tello. He's going to talk about the potential of hydrogen production and use. Pablo Tello is an industrial engineer with over 11 years of experience making assessment for projects in the energetic and financial sector. He's focused on solar energy, rural energy, and lastly, he's been approaching regulatory topics, national strategies, employment analysis, and business development, pre-feasibility assessments in, in the transport industry and others. He worked as a technical advisor in the decarbonization project from the energy sector on Chile in GIZ. Thank you, Pablo, for joining us today. The idea is to work together and generate partnerships so all these topics can be spread throughout the region. So I leave the floor to you. Thank you for being here and you can share
Ya.
your presentation now.
Hola, buen día. ¿Me
Okay,
escuchan
great.
bien?
Good morning. Can you hear
¿Está
me?
bien? Ya. Em, voy a partir con primero, muchas gracias
Okay,
por la
first,
invitación,
thank you
Aida,
for the
y a todo el
invitation
equipo que están
to
allá en
Aida
Centroamérica.
and the whole
Em,
team in Central
hoy
America.
día no somos muchas personas, entonces,
Today, we
pero sí les voy a les
are not
propongo, podemos
too
hacer
many
sin
people,
interrupción,
but
o sea, me pueden interrumpir si tienen alguna duda respecto de las
of course
slides
that
o si
let's
gustan
do this
responderme. Ya
as a conversation. You
dado
can
que tengo todo el
interrupt me
tiempo
if you have
para
any
poder
question,
conversar,
or we
porque
can
es
do it at the end.
un
Maybe at the end
encuentro
we can
entre
have
amigos,
a Q&A
por
session,
supuesto, siempre
or
dejo toda la libertad
also
de
feel free
intervenir.
to interrupt me at
Un
any
tema
time.
más bien práctico, yo no tengo acceso, mientras estoy presentando no les veo,
While
entonces
I'm
no
presenting,
tengo
I
poder ver el
cannot
chat si
see
es que
you,
alguien preguntó por
so I
internet,
cannot
por ahí
see the
me
chat
avisan.
in case there's any question there. I'll help you, Pablo.
Vamos ahora a compartir pantalla.
Okay, I'm gonna share my screen now.
Entonces, compartir por acá. Ya. ¿Están? Partimos, ya. Bueno, muchas gracias nuevamente por la,
Well,
por la presentación.
thank you again for that introduction and for the invitation. We as GIZ in Chile, well, it's an honor and it's a pleasure uh, to do this outreach to create awareness around hydrogen. As Aida said, we are working in the project called Decarbonization of the Chilean electric grid, and this is the last year of the project. One of the elements that the project has within the work and the commitment is hydrogen or green hydrogen, aiming to seek solutions to decarbonize the grid here in Chile. Today, I'm gonna talk about the context, and the definition and actual use, the value chain applications, and some rough numbers related to green hydrogen. As context, these slides, well, I like to present them because even though this is from 2 years ago, the DIZ team
Energía renovable y eficiencia energética en la
and the program of energy efficiency in Chile started in 2014 to start discussing hydrogen. That doesn't mean that on 2014 we did everything. No, it was like the kickoff, and I was working back then in this committee. This committee, this solar energy committee was created back then, and
la
wanted
economía de la
to
energía
strengthen
solar en
the
Chile.
solar energy economy in Chile as an economic subset. And in that discussion, it appeared the need of storage. So we have the question, what are the storage alternatives? What are the carriers that we can use for storage, not only for batteries, but that was the first conversation around hydrogen. And one of the first landmarks here was that GIC promoted the first green hydrogen conferences. We expected 40 participants and we had 120. And we have several landmarks. We have the second conference and the third one a year and a half ago, and the fourth one that was held 2 weeks ago. So as you can see, this has been a constant work,
de que
and
se hiciera todos los estudios en el año 2014.
we had an average on 2014. This took time in order to develop the public policy and to work in a technology and ideas. One of the main elements of this work is the hydrogen book. It's called Hydrogen in Chile. We can disseminate these different contexts. And whenever there's a new technology, we have some new regulations and new regulatory strategies in order to develop the projects in the different countries. And we did this 2.5 years ago, almost 3 years ago. Another element that we work on in these years were technical workshops. We normally invite a company to present an hydrogen-related technology, and we have a 1 hour session with these people, and we also have a lot of questions from the participants. So it's a nice interaction between the technical individuals and the participants. Another element that we've worked on is the assessment of employment potential and looking at this as a more economic subsector. We've also supported the hydrogen regulation in Chile. Not only with the two initial assessments, we supported the Ministry of Energy and also we started the energy partnership in Chile, Germany, and we worked on projects about hydrogen. On 2020, by the end of 2020, and based on conversation with different countries from Latin America and the Caribbean, we created the platform H2LAC. This is an information and knowledge exchange platform, usually between the countries where a GIZ is present. They asked us about our experience and what we could do in the country, working with the ministries and focusing on nitrogen. Another very positive element is the newsletter. Here we have over 2,000 people registered. This is really positive. And twice a month, we share news related to hydrogen, international and national news. On the last year, this last year was very productive. We talked about blending, is the mix of hydrogen with natural gas. We also discussed the cogeneration for H2 production, also the Article 6 and the use of hydrogen in steel, cement, and mining transport. We are conducting some dual combustion studies, also the conversion of thermal electrical plants and other solutions.
Un resumen de todo lo que hemos estado
Just a
haciendo.
summary of everything that we've been doing. And now we're going to cut to the chase. We're going to see what hydrogen is. I think many of you already know this. Hydrogen is the most abundant and the lightest element of the universe. It has several interesting properties. It's not flammable, it's not irritant, it's not corrosive, and it's a very light gas. It has a very light diffusion in case of a leak. And the energy comparison, 1 kg of hydrogen, it has the same energy of 3 kgs of gasoline. That in terms of biomass is really positive, but maybe the most important thing about these attributes is that hydrogen can be used as a fuel and can displace a diesel without any greenhouse emissions, or having very low ones compared to diesel emissions.
Porque lo digo porque cuando uno
And why
produce
do I
hidrógeno,
say this? Because when you produce hydrogen, there are certain traces, but the purity of hydrogen is around 99.98 or 9.99. The current use of hydrogen, well, this graph I found it yesterday. Uh, we use hydrogen in refining oil, and the main use is for chemicals, especially ammonia. If you see this graph a year and a half ago or 2 years ago, that a chemical would be only ammonia,
Utilización
and
que se usa para la reducción
lately hydrogen is being used in the production of steel and iron. That process is going through a technological change. All the plant iron and steel plants. So probably this is going to increase in the future. We talk about hydrogen. How do we imagine the value chain? We have this diagram. It's pretty basic. We have here the energy generation, production of H2, storage, and then transportation to reach a final use. And when we talk about hydrogen, why do we talk about different colors? The molecule is the same. What we are discussing today is, well, originally the world production of hydrogen is 7% of the world production is done through the methane reforming. And that production path generates CO2 emissions. So this is the traditional route, and this is called gray hydrogen, the hydrogen produced this way. If that gray hydrogen, I added carbon capture, any system of capture carbon is going to produce blue hydrogen. And if I change the production route and I don't use methane, but I use water separations through electrolysis, then I obtain green hydrogen. But the energy needs to come from non-conventional renewable energy. That's the main factor to consider. We have the same molecule, and what changes is the energy source and also the production process. Each of these processes or these methods up here generate a certain purity on the hydrogen. The purity is independent from the color. And we're good on time. So when we talk about the production, what are we talking about? We're talking about alkaline electrolyzers,
funciona en base a sosa,
the one on the left,
en base a potasa, y
and
el electrolizador PEM, como el que está a mano derecha,
the EM electrolyzer, like the one on the right.
está
And
utilizando
this is the latest technology, which is the ion exchange. This is the AEM.
¿Cuáles son las diferencias? No traje aquí una slide para empezar a hablar de las diferencias, pero básicamente
I don't have a slide talking about the differences, but this is alkaline. It has more production capacity. This is the oldest technology. This is used in the production of margarine. Many countries that produce margarine or hydrogenated oils, well, they need to put hydrogen on the oil, and this is done with an alkaline electrolyzer. Lately, the PM electrolyzers are a technology alternative that competes with the alkaline ones because it has more ease of operation. The minimum electricity load, well, this is the system, well, the alkaline needs to have at least 20% of energy, of electricity power. If I have an electrolyzer of 1 mega, I need to have 200 kgs. This, along with the non-renewable energy, well, in the case of the PM, it has an energy need of 5%. So I can use this equipment more efficiently if I have a small system, but for larger systems, I have well, we could have a modular production system, so this element is not going to be a problem. The alkaline is cheaper than the PM, and regarding efficiencies, we need to compare them. This is about the size of a microwave oven. I don't know, 25 centimeters or 30. This has 1 kg of power. And what's the advantage of this model? Well, they handle modular production and it can be shipped by plane. So wait, if you're waiting for an alkaline or a PM, well, the waiting list is really long. This is the diagram of a H2 production plant. This is the electrolyzer. The electrolyzer needs to operate at certain temperatures to maintain the optimal operation condition. That's why we always need a heat exchange system. And if we consider this, we're going to have a compression sector. Some alkaline electrolyzers deliver the hydrogen at a 5 bar pressure, while the PM delivers at 30 bar or close to 30 bar. Same for the AEM. I think it's 34 or 30 bar. And here we storage the hydrogen at high pressure, and then we have a refilling station. These are transported on these tubes that would go on the tube trailer. Then regarding storage, I put a G on gas. There are several types of cylinders. And we use a class 4 cylinder that is lighter. It allows to store the hydrogen at a high temperature, here 350 watt, or also could be 700. That depends on the hydrogen type that we need. Another type of storage is the liquefied hydrogen. However, this hydrogen needs to be transported at minus 253 degrees Celsius in order to preserve it in that state. And that temperature, its energy, maintaining this temperature is energy intensive. The liquefaction, it's 10, 12 kW per kilo of hydrogen. So this demands a high energy source. This is cost effective when the plant produces over 10 to 15 tons per day.
En general, estas plantas están, por lo
In
menos
general, these plants, well, at least in the US and Canada, we have several of these liquefied hydrogen plants. When we talk about transport, there are several types of transport. You could have transport via pipeline, road transport, and maritime transport. In the case of the pipelines, well, there are dedicated hydrogen pipelines, but we've been seeing studies in order to mix the hydrogen with natural gas, being able to transport them through pipelines, and also use it as a mixture itself, like a hydrogenated gas. On the other hand, the road transportation is done with this format. These are called tube trailers, but this can also be transported on racks of cylinders. These are the most common when we transport a less amount of hydrogen. These are these 1 meter tubes. These go in 3 by 3, 4 by 4 racks, and they're all linked together with a manifold. So we can deliver it with the stable pressures. Then regarding maritime transport, we have updated this picture. This ship already exists. This is from Project Hystra. In this case, we seek a CO2-free supply chain. We should mention that there are different ways of carrying the hydrogen. It could be liquefied hydrogen, transporting gas hydrogen. It's not the best option, so it's converted into ammonia or ethanol or into an organic liquid.
de acuerdo a sus costos de producción.
And this has been assessed in order to see if it's cost effective or not. And regarding the application, one of the most known is the fuel cell stack. Before, in order to separate the water, I would apply electricity. But now what I do is oxidate the hydrogen with the oxygen taken from air. Then I need to generate a difference in order to generate electricity.
La celda de combustible es un elemento que
The fuel cell is something that generates electricity, but it's not a battery because it doesn't store any energy. It's just an electricity generator that requires hydrogen. And as a storage a backup storage system can be used
principalmente la estabilidad de red. Y a mí me tocó una
as
vez
a feature. It has a very good network stability.
uno de
I
los
went
lugares
to
donde,
Japan,
donde más arrasó
one of the places
el
more
descubrimiento en Fukushima,
impacted by the Fukushima
dicha
earthquake.
universidad tenía justamente un sistema de backup
And the university had a
celda combustible con
backup
baterías
system based
hidrogen-litios,
on fuel cell stacks and
gracias a lo cual
solar energy.
pudieron mantener
Thanks to
la
this, they
aprovechamiento
were
de agua
able to
durante
maintain
ese
the water
periodo
supply during
de la catástrofe
the period after the
y también la
catastrophe,
electricidad, por supuesto.
and also the electricity.
Otra aplicación es la aplicación de logística. El-
Another application is on logistics.
no conocen este caso, pero hace
You may not know this case,
menos de
but
un año
I think
se
less
inauguró
than
en
a
Chile
year
la
ago
primera aplicación logística que
in Chile
es la más,
started the first
digamos,
logistic
podemos decir sencilla,
application.
pero que es más
It's the
rentable
most
también.
simple, but
Es
also the most
auto
profitable.
horquilla, o los
We
forklifts,
have a forklift
ocupa hidrógeno, basa a celda combustible, ocupa hidrógeno y esta se
that
inauguró
uses
en
hydrogen
la minera
based
American
on
Mining
a fuel cell stack. This is done
en
by
Santiago de
the
Chile.
Anglo-American Mining Company.
Algunas ventajas,
Some advantages
quizás la
is that,
modularidad.
well,
Estas
maybe
grúas horquilla tienen
these
una sola
forklifts
celda combustible, o sea, estas
have
grúas horquillas son
the,
eléctricas, eso es lo primero
well,
que
these
habría que decir,
forklifts are electric.
son las
These are
únicas que comparten la
electric
electricidad con una
vehicles,
batería,
but the
el acero
energy source
inoxidable.
instead of a
En algunos
battery
casos
is a fuel cell stack.
retirar es simple,
In some
vienen
cases,
presupuestados, entonces se saca el equipo eléctrico
this
o no, se pide sin el equipo
comes
eléctrico
with
y la
the
fabricante
electric
de combustible
equipment, and
incluyendo ya
the
las
fuel cell
dimensiones
manufacturers
necesarias
are
para
providing
que se
the
puedan
cells
instalar en
at
estos
the right
vehículos
size so it
que
can
son
be
eléctricos.
installed in these electrical
Por una
vehicles.
parte, la,
Is on the one hand
y por otra parte,
for the forklift
ABS
and also
la
the
minera,
H2O network
Hydrogen Refilling Station,
is the hydrogen refilling
en este
station
caso,
that
funciona
delivers
a 450 bar, dependiendo también
hydrogen
obviamente
350 bar,
la
depending on the need or characteristics of the
que
vehicle
necesita.
and according to the fuel that it needs.
Perdón. Otra ventaja de la parte logística es la recarga. La recarga de
One
hidrógeno
advantage of logistics is on the refilling.
relativamente rápida.
This refilling is really quick, no more than 5 minutes
Minutos,
or between
lo
5 to
cual
10
da
minutes.
una ventaja
Obviously,
notoria versus la
this
opción a batería
gives
eléctrica de litio, ion
an
litio.
advantage compared to an electric or lithium battery.
Por otra parte están los buses a celda de combustible también. Son buses
We
eléctricos.
also have the fuel cell stack buses. These are electric buses.
Estructura general
It's
y
electric in
generalmente
general, but
utilizar o hay que
the
ver dónde se
thing is
instala
that we need to see where to install the hydrogen storage
transporte
unit.
público, como todos los que
On the
ustedes
public
conocen,
transportation buses, as the one that you can see here or this one below,
los estanques de
we
almacenamiento se ponen en el
we
techo.
normally put these storage
Los
tanks
buses
on the roof.
que están acá a mano derecha o los
However, on the coach
los,
buses,
los almacenamientos
the
se guardan por acá abajo.
hydrogen is stored down here in the back of the
Una
bus.
foto sumamente reciente de un proyecto de Fortescue en Australia.
This is a really recent picture from buses in Australia, and these are the new buses that were commissioned by Fortescue to be used for mining employees transportation. And this is the picture of the factory.
Es en el transporte de
Another
carga.
application is for the cargo transportation. This is waste disposal trucks. We did a webinar with a company that converts these trucks, or also for heavy material transportation, also for retail trucks, and also for containers. This one here is the fuel cell from Hyundai. Currently,
para transporte de
from
mercancías,
the transportation market.
insumos para el supermercado, ¿qué otras cosas lo han utilizado? También lo están utilizando.
Well, these have been used, well, mainly for those uses. And this is a Chinese truck, FTX. The main use is as a carrier. It is 2 or 3 weeks ago, 150 truck fleet in China. Another application is the power to gas. I talked about H2 injection through networks or also methane production from hydrogen. And you can see here how the different countries, where here we have the percentage for volume that each country accepts regarding the mixture of hydrogen and natural gas.
Resulta también importante o interesante ver cómo el hidrógeno puede ser
To see how hydrogen could be used for ovens or burners.
Una mezcla de gas natural con hidrógeno.
You can use a mix of hydrogen and natural gas or another fuel. It could be liquid fuel mixed with hydrogen. But and this needs to be coordinated with the manufacturer. We've had conversation with Bosch. Bosch is really excited. They already have hydrogen burners, boilers. So eventually they can use a percentage of hydrogen. And we have the byproducts. There's the ammonia production through the Harbour and Bosch method. This could be used as a hydrogen carrier, or we can use hydrogen for green ammonia production. This is one of the main applications that would help in decarbonizing the grid on a world scale.
La creación de combustible sintético.
We also have synthetic fuels. And this is an Audi project. In Chile, we have the H&F project. What we seek for is to produce benzene or kerosene based on green hydrogen locally and produced. And after, we need to synthesize the needed fuel. Regarding cost, this is a small snapshot. On the left, we have the countries investing in H2. South Korea, Japan, Germany, Norway. These numbers in China are increasing.
Sumamente potente en hidrógeno.
China is getting really strong on hydrogen. US, Saudi Arabia, and others. And what are the applications?
¿Para qué se está utilizando el hidrógeno?
So what's the hydrogen being used for? Industry, transport, blending, CHP, heating, chemical industry, synthetic fuels, and H2O power.
Aquí, relativo a los costos de producción y también de los costos de
production costs and capex costs for the electrolyzers. Well, yesterday I tried to update this slide, but I left it the same at the end because we can compare the different technologies.
De todas maneras, la forma en que
But
se está midiendo el costo de producción del
or the
hidrógeno es
way
con el
in which the
LSOH, que es el
cost
costo
being
efectivo
measured
de
is
hidrógeno,
with
de
the
producción de hidrógeno.
LSOH,
Y elemento
of
principal
OH,
para esto,
and the main
la
element for
tecnología,
this,
la PEM, el PEM está en
we
un
have the
TRL
PEM
8 o
technology.
9, está acercándose a un TRL
It's
mucho más
getting close to
superficial, de tal manera que va a ser
9.
igual que el
It's
alcalino,
gonna be
no igual, pero porque el alcalino lleva bastantes décadas de ventaja
closer to
en
the
sistema web,
alkaline,
en el mercado, pero en términos de
because
operación,
the alkaline is
los
older in the
componentes van a
market.
estar mucho
But
más disponibles
regarding
durante los
trade,
próximos
is gonna
años.
be more available within the next
En
3 to
términos de
5
costos
years.
de electrolizador,
Regarding electrolyzers
eh,
costs,
podemos ver el SOIC
we can
representa, el SOIC
see
es una tecnología
the
de óxido
week.
sólido, es
This is the
una
solid
tecnología de TRL
oxide
de grado 4 o
technology.
5.
We have
Entonces,
a
estos
4 to
valores son
5
sumamente
uh,
aproximados.
TRL. So
No
these are
necesariamente fiables, porque si bien tenemos
approximate values.
las fuentes, son valores aproximados. Y lo
Even though we have
interesante
sources, but these
es ver
are
cómo se
approximate
comporta
values.
el
And we
alcalino
need to
bajo
see how
distintos
the alkaline
escenarios,
behaves
y obviamente el
under
bajo
different
distintos estos
scenarios.
valores naturalmente están bajando, están
These
reduciendo
values are being reduced,
pero lo que también es importante considerar
but
es que
something that is important to consider
a veces no hay
is
que quedarse
that
solamente con el costo del
sometimes
electrolizador, sino que
we
también
don't
con el
need
costo del
just the
sistema.
electrolyzer cost, but
Estos
also
sistemas
the system cost.
tienen una gran cantidad de
These
tuberías, de piping, de
systems
compresores,
have a lot of
de
piping,
auxiliares
compressors, and
que a
auxiliary
veces
equipment,
en estos estudios no están considerados.
and sometimes they are not
Uno
considered
tiene que tener
on the
tiene que tener un
studies.
buen ojo para poder
So
comparar
you need to
y hacer
be,
un análisis comparativo igual entre
you need to
tecnologías
have
y soluciones.
a proper analysis.
Finalmente, los costos de transporte.
Finally, the transportation costs.
Aquí a la izquierda pueden ver
On the left, you can
que
see
esto es comparativamente qué es lo que más conviene para poder transportar el
this is a
hidrógeno, cómo se hace
comparison to see what's the
más viable.
best way to
El C
carry the hydrogen.
es de comprimido.
C
Y
is for compressed,
y naturalmente
and
a escalas locales o las distancias
on local
pues
scale,
hace sentido
it makes
hidrógeno
sense
comprimido o
to
hidrógeno
have compressed
producido
hydrogen or
en volúmenes mayores,
being
y a
transported
medida que
via
se va
pipelines. And
alejando la
when
distancia,
the distance are
hace más sentido
greater,
hacer un orgánico,
it's
es decir,
better to
liquefiar
use an
hydrogen
organic.
carrier,
This is
o
liquefied organic
amoníaco,
hydrogen
metanol
carriers
u otro
or
carrier.
ammonia, methanol, or others.
Muchas gracias y
Thank you very much, and I'm available for any question.
Muchísimas gracias, Pablo, por tu presentación. Definitivamente
Thank
muy
you very
importante
much, Pablo, for this presentation.
los aspectos
For us, it's
bastante
very
básicos y
important
cómo está
to understand
en torno a esto.
these aspects.
Una pregunta en el chat y tal
I
vez te
have a
pregunto,
question
¿cuál
from
es
the
la
chat,
gráfica donde pones qué tipo de
and
hidrógeno
can you
sería
go to the
a esto?
hydrogen types slide? I don't know if you want
A Pablo.
to ask the question yourself, Sophia.
No sé si tienes micrófono, Sofía.
Can you open your mic, Sophia?
Bueno, creo que no nos escucha, pero tal vez acá.
Maybe she can't hear us, but she wrote a question on the chat. She said that following the sequence of the hydrogen colors, you talked about gray, green, blue hydrogen. She says, I understand that the biomass would generate brown and black hydrogen. Could you explain a bit more? So I think it would be helpful to have the slide on so everyone can understand Sophia's question.
Sí, espérate, voy a compartir.
Ay, gracias, ya lo sé.
Está compartiendo, ¿no es cierto?
Sí, correcto. Todavía no está en modo
Ajá.
presentación.
You
Entonces,
can see it, right?
mi pregunta es
Yes.
si yo uso la biomasa
Is
mediante
if I
una
use the
conversión.
biomass through a
Esa es la línea, ¿no?
thermochemical conversion,
Se utiliza biomasa y gasificación.
if we use the biomass and
Sí,
Mm,
es esa, por biomasa y conversión
is
termoquímica.
that one.
Por
The
gasificación,
biomass
que es
and a
hidrógeno
thermochemical
café,
conversion, we would have
que no
brown
es
and
uno
black
de
hydrogen.
hidrógeno verde o azul.
no, sí,
We
perfectamente.
don't have of the green or blue hydrogen.
Sí, eventualmente, normalmente
Yes,
nosotros no, sí, yo no
normally,
vengo del mundo de la biomasa, por lo tanto el proceso,
I don't come from the
pero
biomass industry,
si
but
yo generara biomasa,
if
a ver,
I generate
el
biomass,
diagrama es un diagrama no
first,
está
this
escrito,
diagram
escrito en piedra y la
is
discusión de que
not
si es
written
verde
in
o no,
stone.
o si
And the
acepta
discussion,
ser
if it's
certificado como
green or
ingeniero verde,
not,
es una discusión que se está dando hoy en día en
the
Europa.
discussion
De hecho, la directiva, la red,
that is
es una
very
directiva
current in Europe.
dos, todavía no se ha definido
And
y los combustibles
the,
orgánicos están jugando un papel importante
the
en
organic
en la
fuels
discusión.
are
Por lo tanto,
playing an important
esto yo lo
part in this
lo
discussion.
tómelo
So
como como una aproximación, pero
take
si yo
this as an
hago
approach.
gasificación efectiva de la
But if
biomasa,
I
pero
do
yo
an
aseguro
effect
que ese ciclo de la
gasification of the
biomasa es
biomass
un
and I
ciclo
ensure that this
neutro en emisiones
cycle
de CO2,
is neutral
como
on
normalmente
CO2
es para el
emissions,
caso de la producción de
as
electricidad, como es
it's
aceptable la
as
producción de electricidad,
normally is
es muy
for
probable que uno pudiera
power generation, then
hacer
it would
justificar
be probable
producto
that
de
this could be
hidrógeno
justified
verde
as a green
o de
hydrogen
un hidrógeno azul si es que
or a blue hydrogen
emitiendo
if
CO2.
I
Pero
emit a bit of
va a
CO2.
depender netamente de cómo yo lo certifique. Esto es más bien
It
importante
also depends on how
el
I
objetivo del
certify
color.
this.
El color lo que busca es,
What the color
en
coding
paralelo
seeks
después,
is
tener la
to
revisión de certificación de un combustible
have a
o sin hacer emisiones
certification
o emisiones capturadas.
for fuels with zero emissions or capture emissions. Thank you, Pablo. And Armando says that when the biomass is a residue of some process,
Sí,
the hydrogen can be considered as
está en la
neutral
parte,
carbon.
la parte sí,
Okay.
era natural.
They are really testing me with these questions.
Y yo, o sea, yo creo que la
I
discusión
think
va hacia el mismo, va en el mismo
that
sentido.
the discussion
Chile
goes
está pensando en
towards
exportar
the
hidrógeno.
direct.
Entonces la
Chile is
discusión que
thinking
hemos
about
tenido y
exported
que he estado
hydrogen.
trabajando bastante,
I've been
ok, ¿cuál es el
working
hidrógeno que me están
on
pidiendo o cuál es
what's the hydrogen that is
me
being
están pidiendo
requested
en Europa?
or
Y
what
lamentablemente
are the considerations that they need in
la
Europe.
directiva 2, que es el Red 2, con
The
números romanos,
network
tiene
2
los non
have
NRFN,
has
como los non, no recuerdo la sigla completa, pero es como los combustibles
the acronym, but it's
biológicos, ¿no?
are the
Y yo sé que está en este minuto en la
organic
discusión
fuels, and
de qué es lo que se va a
we are
considerar o
discussing
como
what
combustible
is going to be
biológico o
considered
no,
as a fuel of biological origin and what not, and what is the amount of emissions that can be accepted
gramos de CO2 por kilo de
in
hidrógeno producido
gram,
para que
grams of
sea un hidrógeno, por así decirlo,
CO2
verde.
against kg of hydrogen in order to be
Como les digo, no
considered
es algo que
green.
esté escrito en piedra,
As I said,
significa
this is not
las
written in
consultas,
stone.
porque
This is a
cuando la
very good
biomasa es
question
residuo de
because
algún
it says
proceso,
when
los
the
residuos,
biomass
claro, en todos los
is a
casos,
residue of the process.
el
Well,
carbono
in
neutral
every
se entiende como
case,
biomasa,
it could be
porque se
considered
entiende que la biomasa también
carbon
capturó el
neutral
carbono
when I have
de todos
biomass because
los
the
sistemas
biomass
fotosíntesis, ¿no?
capture
Para cuando
all
estuvo creciendo.
the
Entonces,
carbon.
pero ese ciclo particular
But
no,
that,
yo creo que es una buena temática de discusión
well, I think it would be
para
a
los
great
que
topic
ustedes
of discussion
como biomasa combustible la están considerando y discutiendo en la red.
for the network of bioenergy.
Para aplicarse en este soporte se
Marco,
necesita que los
to
vehículos sean
apply this
eléctricos,
in
entonces
transportation,
sí y
do
no.
we need electrical
En general,
vehicles?
la
Well,
tendencia
yes
que
and
existe
no.
es que los vehículos a celda de combustible
The
son
fuel
su puro
cells
motor
type
son
vehicles, technically they are electric vehicles. It's an electrical vehicles where you can add
que utilizan los vehículos
a fuel cell stack and you can use less batteries than in an electrical vehicle. But we are doing the engine company is doing an assessment using hydrogen directly in internal combustion engines.
está comercialmente.
This is not
De hecho, hace muy poco
eliminated and
Yamaha
it's operative. Actually, Yamaha
presentó un
in
motor
a race in Japan, they introduced a racing engine that used hydrogen. So it's
mezcla
not
también
uncommon. We know what happens when we mix hydrogen with fossil fuels, with benzene.
ocurre.
So since we know what happens, then we know how can this be adapted. The only issue is the cost to produce those engines or to
A nivel ya comercial mundial.
produce this
Por
on
acá,
a world scale.
dice, en Colombia conozco un caso
Armando says, in Colombia, I know a case like this. A brewing company has a boiler that uses residues from wood. They generate gas synthesis. There are several ways to use the hydrogen or to synthesize gas. The chemists know this very well. What is happening today is that around the world there's a boom, there's a hype that generates or is generating a new economy, and also aiming to reduce the greenhouse gases. There are a lot of people working with hydrogen for many years now, and they say, well, we already know this. Well, people who work with hydrogen know this, and right now I think it's more spread and disseminated. Pablo, for us to a community, it's really interesting to understand that hydrogen can be produced from oil itself, from solar, wind, and hydro energy, and also with bioenergy. We could use even algae or biomass. And for me, it's really important to know what are the hydrogen classification. This is a growing, as you say, this is nothing new, but internationally, there's been a boom on the demand for renewable energies
Energéticas y vamos a hacerlo de petróleo, el hidrógeno.
because
Pero me imagino que también hay aplicaciones
it wouldn't make any sense to change the grid to still using fossil fuels. So it's important to understand that this is growing, the demand is growing in Europe.
Creciendo la demanda y lo que veo yo también es que la
And what I see is that in the Latin American region, there's a lot of potential. If we have biomass, well, we have the potential to produce hydrogen. And we saw your slides that many of the hydrogen is exported. It's not used, well, it's used locally, but we export a lot of it.
Acá los que más van a sufrir o pueden sufrir es Trinidad y Tobago, que es uno de los mayores exportadores de gas
ones that
natural.
are going to be impacted most is Trinidad and Tobago because they are the main exporters of natural gas.
Es entregada por Trinidad y Tobago. Entonces, efectivamente, ¿cómo hay que verlo? No sé, ahora nosotros estamos trabajando con República Dominicana, por ejemplo.
We are working with Dominican Republic.
Para nosotros, el caso de República Dominicana también.
And for the Dominican Republic as well, they
Por ejemplo,
don't have any natural gas waste. They produce with solar or wind energy.
distintas líneas de
But in your
producción
case,
energética a través de
that you're thinking about the different energy line, well, you have more possibilities. I think that for us,
con mayor profundidad en esa temática,
well, we had
pero
to get into
mencionaba
the
recién
topic
Armando,
more
lo
deeply,
mencionas
but
tú,
as Armando and you
varias
mentioned,
vías. O sea, yo creo que
there are several ways.
eh,
I think
es natural o sería natural
it would
preguntar,
be natural
revisar
to,
cuáles son esas vías, o sea, a qué me
for,
lleva
to ask what are those
utilización de
ways.
biomasa, a qué me lleva otra línea de utilización de biomasa y
What can I
cuál es más
do
o
with
menos
this route or this other route, and
para la producción de
which one is
hidrógeno,
more
tiene sentido o
efficient
no tiene sentido
to
que lo haga.
produce hydrogen?
Y, y también, ¿por qué? Porque claro, porque si yo voy a hacer un biocombustible,
Because if I'm going to produce a
hacer el biocombustible,
biofuel,
tiene sentido hacer el
we need to
biocombustible,
see
utilizar el
if it's
biocombustible
worth
para
it or
producir
not,
hidrógeno para
or
o
if it's
analizar
worth to use biofuels to produce hydrogen.
mucho de eficiencias del ciclo completo para
We need to see the
que yo
complete
necesito,
cycle
estoy
efficiency.
utilizando esa fuente energética.
Bueno, y hablan aquí que si solo tal vez la última pregunta porque nos pasamos 5
And
minutos.
this is the last question because we are already over the time. There's the need to
Sí,
adapt legislation to produce and use hydrogen. Yes,
es una pregunta que surge, me ha tocado de cerca estar trabajando y acompañando al
I've
Ministerio de
worked
Energía
very closely with the Ministry of
en
Energy
Chile ya estamos
regarding these topics.
reglamentos
In
generales.
Chile, we are discussing the general
Yo creo que hay dos
regulation
elementos, o sea,
for hydrogen.
para no entorpecer el desarrollo del proyecto, ¿no? Es
First, to not
primero es ver
obstruct the
aceptar el
development,
hidrógeno que a lo mejor como
we
un
need to
uso, fue el primer
accept
paso que dimos acá en
hydrogen
Chile.
as a better fuel. That was the
Eso
first
es
step that we took in
es bien
Chile.
fuerte porque antes lo veía el
And
Ministerio de
that's
Salud.
really big
No
because
tenía
this was
política de hidrógeno respecto a
supervised
lo que
by
podía
the
producir el hidrógeno
Ministry of
almacenado,
Health,
como eventualmente daños, pero porque no estaba considerado
because
estaba
it
considerado
was
como una mercancía
considered
peligrosa, ¿no?
as a fuel, it was considered as a
Que casi todos
hazardous
los
material.
químicos están considerados en esa lista, o sea,
Almost all
básicamente
chemical,
reales. Nadie se asuste.
almost all chemicals are considered under that same category. So the first thing is
¿Cómo considerar o
see
conceptualizar el hidrógeno
how
como compuesto, como
should we
elemento, si es un
regard
energético o no es un
hydrogen, if
si
it's
es un energético? Y
an
yo lo
energy
digo
source
porque
or
ahora
not? And
salta
why do I
la
say it?
pregunta con el
Because
amoníaco. El amoníaco va a ser considerado un
there's a
energético.
question about ammonia. Is ammonia going to be considered an energy source or not?
Ya está, pero
Then,
los
well,
demás están
methanol
todos
is already
empezaron a
considered,
sumarse
but
los distintos componentes.
there's going to be a
Y
different
una vez
components.
teniendo eso claro,
And once we are clear
hay que
on
pensar
this,
también o le hacer un
we need to
lanzamiento
think,
de la línea base, cómo están las normas en el país.
we need to see
Y,
the baseline regarding
definir si es necesario o no es
connection.
necesario tener
Then
un
we need to
reglamento
see
particular. Acá
if
en
we
Chile
need
estimamos que sí era
a
necesario
specific regulation. Here in
para
Chile, it
normar un
was
poco las
necessary
construcciones,
to
pero el spoiler alert es que
regulate the
NFPA2 es como una de
those
las normas
production
más
process, but
utilizadas.
this is one of
Algunas
the
normas europeas
most
o también algunos
used,
estándares
the
internacionales
AFP2, and we also use some
en lo que
European and
en la
international
legislación local,
standards.
lo que uno hace es llamar a los distintos articulados o adaptar ciertas cosas. Recuerdo, bueno, Chile tiene
So
una
what
realidad
we
así,
do in the local
ciertos elementos que
regulation,
nuestra
we
normativa
reference
está por
these
sobre
codes.
la internacional o tiene
It
ciertas
is except
particularidades
with
en
the
ciertas construcciones,
some
pero este tipo
regulations
de cosas
about
y articulado es
seismic
principalmente muy cercano
code,
a la NFPA2, que
but
también
it's
eso tiene
really
relación
close
con
to
la
the
práctica que hacen las empresas
ADPF2,
internacionales que utilizan hidrógeno.
and
Linde,
many companies that produce hydrogen do the same thing.
a esas empresas, ellas usan
You go to
normativa
those companies, they
no solo
use
comercial, sino que muchas veces
regulations
financiera. Entonces, acá
based
tenemos que
on
tener la
safety.
normativa que uno usa, hay dos
So
líneas, una
the regulations that we
mercado para
use,
implementar el hidrógeno, una
there's a
de
market line
entonces,
and a safety
todo lo
line.
que uno esté trabajando, la idea es que
So
sea por
the
seguridad
idea is to
envíe
prioritize
el mensaje
safety,
a los países
and the
a pensar
message
que
for the other countries is
haya dos vías
think
de trabajo, una
about
un reglamento
two work with. One is the regulation on long term, and there's another one of a special project. This way we can facilitate
Si no, van a
the
estar
development of projects. If not, we need to wait
no sé,
for the regulations to be ready. This could take
para
3 or years, and
proyectos o
then
atraer
we're gonna
inversión
start
de hidrógeno verde. Entonces,
the
el llamado es
green
tener
energy
días
production projects.
así
So
lo estamos
we
haciendo
can
acá,
have
ya
parallel alternatives, and this has worked very well here in Chile. Okay, Pablo, thank you very much for your time. We are already running late. This has been really interesting. I think it would be important to keep exchanging experience, and we have shared again on the chat the registration form, and also there's the WhatsApp group. You can also share with us any special topic that you would like to discuss. This way we can keep exchanging information. And the community is composed by 15 countries. And the idea is to have a very active year. Thank you very much. Please register in the community and to the WhatsApp group. Thank you, Pablo. Goodbye, everybody. Thank you very much. Thank you, Pablo.